Black holes started as a theoretical oddity, a mathematical ghost predicted by Einstein's equations. And now they sit at the center of some of the biggest cosmic questions we have. Imagine regions of space where gravity bends reality so hard that nothing, not even light, gets to escape the party. And yet, despite decades of research, the truth is that we're still wandering in the dark, trying to understand what they really are. The mystery begins with how black holes form. We know the basics. A massive star burns through its fuel, collapses under its own weight, and the density ramps up until space and time buckle. But the exact moment of collapse, the transition from star to singularity, is something we can't observe. Physics sort of throws its hands up because the math becomes infinite and uncooperative. Some scientists think this singularity might not even be real. It might just be a sign that our theories are incomplete. The event horizon, the border you can't return from, adds more puzzle pieces. It's a boundary that looks deceptively simple. Cross it, and you're gone. But even here, mysteries creep in. For instance, what actually happens to information that falls into a black hole? According to quantum physics, information should never vanish. According to black holes, well, that's exactly what they seem to do. This disagreement sparked an iconic debate called the information paradox, with Hawking on one side and practically every quantum physicist on the other. Later theories tried to patch things up. Maybe information is scrambled on the event horizon. Maybe it leaks out in Hawking radiation. Maybe the horizon isn't truly smooth. Maybe it's a firewall of energetic particles. The cosmic irony is that we don't know which idea is correct, and every solution seems to break something else. Another mystery sits at the center. What is the singularity actually like? If you fell in theory you'd be stretched like space spaghetti until you're thinner than a strand of hair. But that's classical physics talking. At extremely tiny scales, quantum mechanics should take over. Maybe space-time becomes granular or foamy. Maybe the singularity never forms because the collapse stabilizes into something exotic like a Planck-sized core. Or maybe black holes are portals to new regions of the universe, little bubbles that form baby universes inside them. Some physicists seriously consider this, that our own universe could have been born inside a black hole from another universe. It's a wild idea, but when you stare deep enough into gravitational chaos, wild ideas start sounding reasonable. Even the outsides of black holes aren't quiet. The area around the event horizon is a violent place where matter spirals inward, heats up, and emits incredible amounts of energy. But the way this matter moves, how magnetic fields twist around it, how jets of material blast out faster than any human-made machine can dream of achieving, all of that is still partly a guessing game. We've taken photos of black holes now, sure, but they're blurry, like trying to recognize your friend in a fog from 2 blocks away. The details are still hidden, waiting for better telescopes. And let's talk about supermassive black holes. Every large galaxy has one sitting in the center like a quiet boss. How did they get so big so quickly in the early universe? Some of them already had millions of solar masses when the universe was less than 1 billion years old. Stars didn't have enough time to grow, explode, and merge enough times to create something that huge. So were these black holes born massive from the start? Or did they gobble matter in a way we don't yet understand? Nobody has a satisfying answer. There's also the question of whether black holes even stay black forever. Hawking radiation predicts that they slowly evaporate over unimaginable timescales. For supermassive black holes, this evaporation takes so long that the universe itself might have ended long before the black hole disappears. But we've never observed Hawking radiation directly. It's a beautiful equation on paper, but we can't confirm it yet. Until we do, we don't know for sure whether black holes shrink into nothing or leave behind a final piece of ultra-dense matter. What makes black holes so captivating is that they sit at the intersection of our 2 biggest theories, general relativity and quantum mechanics. Relativity says gravity bends space like soft clay. Quantum physics says the universe is built from tiny vibrating energy packets. When you try to apply both theories inside a black hole, the math breaks apart. It's like putting two puzzle pieces together that almost fit, but not quite. Scientists take this as a huge hint. Black holes might be the key to a unified theory of physics, the one equation to rule them all. But until that breakthrough happens, black holes remain cosmic riddles with half-solved clues. What we do know is that black holes aren't just destructive monsters. They shape galaxies, stir up cosmic gas, influence star formation, and maybe even determine the fate of entire regions of space. Without them, the universe would look completely different. They're engines of chaos and order at the same time. In the end, the biggest mystery might be this. Every new discovery about black holes seems to open two more doors full of questions. The deeper we look, the stranger things get. It's almost like the universe keeps these phenomena deliberately strange, just to remind us how little we truly understand. And maybe that's the best part. Black holes challenge our imagination, push the boundaries of science, and keep us wondering what lies beyond the event horizon, waiting to be discovered.